Welcome to Biology, My Passion. I am Soumya Harikrishna. Today we are going to learn the first chapter in chemistry in class 10, chemical reactions and equations. So we will try to make it very simple. Basic concepts that we have to study are what are chemical equations, then how do you balance a chemical equation, and types of reactions. So before we jump into chemical reactions, there are actually two types of changes that we see around. Which are they? Physical changes and chemical changes. In smaller classes itself, you have learned the differences between them. In a physical change, what is happening? It is a temporary change which can be reversible and no new substances forming there. Whereas when we come to chemical changes, new substances are forming there and also it is irreversible. We cannot get back the substances which involved in that change. In this chapter, we are focusing on chemical changes. So when chemical change occurs, it is followed by a chemical reaction. Whenever a chemical reaction is occurring, certain atoms or molecules of a species, they rearrange and make some new substances or species. So the atoms or molecules which are getting involved are called the reactants, and whatever we are getting are called the products. So this we can represent in the form of a chemical equation also. Now what all things can happen during a chemical reaction? Let us discuss. If you take the example of rusting of iron, iron, if you keep simply outside exposed to oxygen and moisture, it will form a brown flaky substance over it, and that is called a rust. The chemical formula of rust is Fe2O3.HXH2O. Here number of water molecules is given as X because it keeps changing. Now Fe2O3, what is the chemical equation here? In the last video we have learned how to make chemical equations, valency, valence electron, all basic concepts of chemistry in class 10 or required for class 10. So I request you, if you have not watched that video, you have to go learn that first. It's not only that watching first, take down the points, learn those concepts very thoroughly before you start class 10 portions. Okay, so here we know iron has a valency of 3. If the higher valency, what is the name that we are giving, ferrous or ferric? Ferric. All those details we discussed in the previous video. So hydrated ferric, because water molecule is here, so hydrated ferric oxide is the chemical formula of rust. Another equation we can see here, burning of magnesium ribbon. So magnesium ribbon, simply when we are keeping in the normal condition, it reacts with the oxygen in the atmosphere and forms a thin layer of magnesium oxide over it. So prior to burning it, we need to remove that magnesium oxide. For that, we rub the surface of the magnesium ribbon using a kind of sandpaper. Sandpaper we use to clean the surface. It's a very rough paper. So that will remove all the magnesium oxide. Now we have to show it in a flame. What will you observe? You will see a brilliant dazzling flame. This magnesium ribbon burns in the fire with a brilliant dazzling flame, and also heat and light will be emitted. At the end, this ribbon will turn into a powder. That powder is called a magnesium oxide. That's the product that we are getting. Next is a reaction between potassium iodide and lead nitrate. If you add these two substances, you will find the formation of a yellow color precipitate at the bottom of the test tube. Here, what do you mean by precipitate? In a solution, if something is not dissolving, that will get sedimented, or that will be there. Sometimes it can be suspended also. So such undissolved substances are called a precipitate. Certain reactions form precipitate, that is a characteristic. So here, what is the color of the precipitate? Yellow precipitate of lead iodide is forming here. Now another chemical change, reaction of zinc. If you take some zinc metal, it is very lightweight, silver color metal. If you take it in a test tube, to that you add some hydrochloric acid or sulfuric acid. So basically throughout the 10th standard you should know 3 main acids with their formula. One is hydrochloric acid, strong acids, hydrochloric acid HCl, sulfuric acid H2SO4, and nitric acid HNO3. These 3 by heart it, because you will have to keep using them very often. So when the acid is added to zinc, zinc is a metal. what is the reaction? You will see a kind of a gas is coming out. Okay, so this gas will be going upward, that is the gas is coming out, but we do not know which gas it is because it's a colorless gas. So we can test the presence of this gas. If you bring a flame or a matchstick near it, it will burn with a pop sound. So whenever you get that pop sound in testing a gas, that gas is called a hydrogen. So it's a hydrogen confirmatory test. You are in class 10, you are learning only two gases confirmation. One is hydrogen, another one is carbon dioxide. Carbon dioxide we will learn in due course of time. So hydrogen, how will you test for the presence? Either you have to bring it near the mouth of the test tube, a matchstick or a match splint, which will burn with a pop sound, or you can collect it and then burn it, then also this pop sound, or you can pass it through a soap solution so that this gas will get filled inside the bubbles. When we again burn this bubbles, you will get that pop sound. So pop sound is the characteristic feature of confirmatory test for hydrogen gas evolution. So whenever we are collecting hydrogen, usually hydrogen is coming above the water level, displacing the water downwards. So it is downward displacement happening in case of hydrogen gas. Usually MCQ, sometimes I have seen this question, the separation of hydrogen or collection of hydrogen is downward displacement of water, upward displacement of water, like that. So there the answer is downward displacement of water. Okay, keep in mind that. It's not often asked, but I have seen the questions like that. So these are the different chemical changes that we discussed. What are the observations we are seeing here? Are they same? No. In the first case, what we saw was the formation of a brown flaky substance over the substance. So color also changing and the texture also changing. Some material is forming. In the second case, we saw dazzling flame with the heat and light. At the same time, a powder is forming. Here magnesium we took was a metal and oxygen is a gas, but as a result what are we getting? A powder we are getting. So a state of change is happening here. Then coming to potassium iodide added to lead nitrate, there we are seeing a new precipitate is forming and there observed a color difference also. Then the next one, we are seeing evolution of a gas, but in this reaction some amount of heat is also evolved. Such reactions are called an exothermic reaction. Exo means what? Outside. Therma means heat. Heat is liberated out. So evolution of heat also happens in this case. So in each of these experiments our observations were different. So any of this is happening, we can say that a chemical reaction has taken place or a chemical change has occurred. As I told, chemical change means a chemical reaction is happening. Chemical reaction we can represent in the form of chemical equations. Now what are the main changes occurring during a chemical change? Change in color, as in case of rusting of iron, change of physical state of the substance, evolution of the gas, formation of a precipitate and change in temperature. So if you observe any one of this or many of this or more than one of this together, we can say that a chemical reaction has occurred. Chemical changes are results of chemical reactions. Chemical reactions we can represent using chemical equations. So chemical equations can be of two types. One is word equations, second is symbol equations. So simply if we put those reactions or changes in words, that is called a word equation. So whenever we are writing a chemical equation, we know the substances or species of atoms and molecules involving in a reaction or participating in a reaction are called the reactants. So we write reactants to the left hand side, LHS, with a plus sign in between them. So if more than one is there, we add by plus sign. And whatever we get, that we write on the right hand side, they are the products. Product also, if more than one are there, we connect them using plus sign. Now between the reactants or the LHS and RHS, we have the products. We put an arrow mark to separate them. And the direction of the arrow mark is always towards the product. So this is the word equation that I have shown here. But every time writing a word equation is difficult for us. So usually what do we use? We use chemical symbols for representing it in a very simple way. So in this case, if I write here, magnesium, I know the formula is Mg. Whereas oxygen is O2. So I can write Mg plus O2 gives magnesium oxide is MgO. The same way, lead nitrate, PbNO3 twice. That is lead nitrate. All these equations how to write we discussed in the previous video. Then potassium iodide is Ki. So what do I get? Lead iodide, that is PbI2, and potassium nitrate KNO3. So this is the chemical equation. Now we have zinc Zn, hydrochloric acid HCl gives zinc chloride is a ZnCl2 plus hydrogen is a H2. So if you represent like this is called a chemical equation, which is in the form of a symbol equations. But when we write symbol equations, we just have to see that their number of atoms or molecules are same on both the sides. Here if you check the number of atoms on the left hand side and right hand side, we may find out that they are not actually same. For example, here 1 mg, here also 1 mg, here O2 there, but here only O. So O is not equal. The same way here the nitrate is twice, but here only one time. The same way I is only 1, here 2 times. So there is an imbalance that we are seeing. Such equations are called an unbalanced equation, or they are called a skeletal equation. So whenever we are writing an equation, we have to make sure that the equation is balanced. Why it is necessary? Because it is very essential to satisfy the requirement of law of conservation of mass. In class 9 you learn law of conservation of mass, that mass can neither be created nor destroyed in a chemical reaction. So total mass of all the substances in a chemical reaction or reactants is equal to the total mass of products in a chemical reaction. So before the reaction and after the reaction, the total mass of the substances should remain equal. And one more thing to remember here is, during a chemical reaction, atoms of a particular element is not going to get converted into atom of another element. Okay, the same way, now no more atoms can be added from outside, nowhere no new things can come. At the same way, nothing can go out also. So whatever things we are writing on the left hand side, they will also be appearing on the right hand side, only with some rearrangement only. So many students ask, after this many chapters we learn about equations, they ask, ma'am, should we balance the equation? Of course, whenever you are writing a chemical equation, you have to balance it. That's why we are learning balancing in the initial first chapter itself, so that you will naturally balance it in the coming chapters. Now we are going to study another important concept, that is balancing of chemical equation. This concept you should understand well, then you have to practice well. So in your textbook, hit and trial method is given. It is a step-by-step procedure. Initially you may have to do all these steps very systematically, but once you are completely practiced, you will be very quickly doing the balancing. So you will find it very easy over a period of time with your practice. So let us take one simple equation, zinc plus sulfuric acid, zinc sulfate plus hydrogen. Hydrogen evolution of gas we already saw. So equations are written. Means right hand side, left hand side reactants, and right hand side products are written. Now we already learned that mass should be equal. No atom is added, no atom is removed, only they will rearrange, right? And here whatever is here, suppose here is the H2SO4. H2SO4 is a compound with the 2 atoms of hydrogen and 1 sulfate. Right? Otherwise 1 sulfur and 4 oxygen atoms. So if you make it right H3SO4, then the compound is changing. It's not sulfuric acid anymore. So we should not make any changes in the equation or chemical symbol. Understood? So to refrain you from doing such things, initially what you can do is, these are all required only in initial stage, later you will become very expert in this. So this box is done so that we put it inside a box and we locked. So now you are not allowed to change anything inside the box. Whatever you can change is only here. Suppose I write here number 2. This is applicable to everything inside. So now hydrogen will become already 2 there. You have to multiply with this. 2 into 2, 4. Sulfur becomes 2. Oxygen becomes 4 into 2, 8. The same way if I make it 3 here. then hydrogen becomes 2 into 3, 6. So this is how we are adding the number in the equation. Understood? So now first we have to check left hand side and right hand side are matching. So let us take one by one. For you to go little systematically, what you can do is, whichever is the metal, consider metal first. Once you equalize the metal on both sides, then you find out which is the non-metal and go for it. If non-metal is also over, then you can go for oxygen. Once oxygen is also balanced, then only you go for hydrogen at the end. So if you follow this system, then it will be more easy and complication can be lessened or lower. So here, first we see LHS and RHS I am writing. Left hand side zinc is a metal. So zinc being a metal, I am considering zinc first. So here left hand side of the equation, totally there is only one atom of zinc. Right hand side also only one zinc. So 1 and 1 equal. Next I am going for sulfate. Suppose sometimes sulfate, nitrate, carbonate, all these, they appear as such on the other side. Like sulfate here, sulfate there also. Nitrate here, nitrate there also. Carbonate here, carbonate there also. So as such it is repeating, you can consider them as a whole. But sometimes this sulfate will separate into maybe sulfur dioxide or sulfur and oxygen separate. So in such case, take each element separately. So here since sulfate is appearing here and here, we can take it as sulfate as a whole. Here 1, this side also 1. So barabar. Then comes hydrogen. Left hand side how many hydrogen? 2 hydrogen atoms are there. Right hand side also 2 are there. So it is barabar. So in this case, we can say that the equation is already balanced. Then why did I give a balanced equation in the beginning? Because you don't get confused if you get a question like this. Sometimes in the question paper, you may get a 3 or 4 questions to balance. But out of that, one may be already balanced. Then you will be wondering, oh my God, where to put a number and all. You will spend unnecessarily time. If you are feeling or you are finding that already it is balanced, leave it like that. Just write it is balanced equation. Okay. Let us see another skeletal equation. Magnesium plus hydrochloric acid gives magnesium chloride plus hydrogen. Instead of zinc, we are taking magnesium. So metal plus acid, what is the gas? It will be hydrogen. We already saw that previously. So here magnesium. In the left hand side, how many magnesium? Magnesium being metal, I am taking magnesium first. How many magnesium? 1 magnesium. Right hand side also 1. So it is equal. Now coming to chlorine. Then chlorine is left side 1, right side 2 are there. So this side 2, this side 1. Addition is not possible, only multiplication. So if I multiply this side by 2, I can make chlorine equal on both the sides. But am I supposed to multiply here? No, because it is already locked inside a box. I am not supposed to touch the box. I can put a 2 here. Okay, so chlorine became 2, this side also 2. Then immediately I have to go back and see the previous one has not changed. Magnesium 1, magnesium still 1. Okay, no problem. Chlorine 2 here also. Now we are coming to hydrogen. Now hydrogen is 2 times, right? So hydrogen is 2. This side how many? Already 2 are there. So hydrogen is also equal. So what is our balanced equation now? Mg plus 2HCl gives MgCl2 plus H2. Another reaction, when iron reacts with the water, ferric oxide and the hydrogen gas is produced. So here iron is a metal, so I am taking metal first, iron, then oxygen, then hydrogen. So how many iron we have in the left hand side? Only 1. Right hand side we have 2. So what I can do is, left hand side I can multiply by 2 so that both the sides will be equal. So now left hand side 2, right hand side also 2, it is done. Okay, but not finalized, you have to recheck every time. Then next we are considering oxygen. Here oxygen is only 1. This side oxygen is 3. So in order to make it 3, we can multiply by 3 here. Can I do here? No, it is inside the box. So I will put 3 here. So now 3 oxygen this side, 3 oxygen that side. Now again we will cross check once again. Iron is 2 here, iron is still 2 here, no problem. Oxygen is 3 here, oxygen is 3 here also. Now coming to hydrogen, now hydrogen 3 into 2, 6 are there, right? 3 into 2, 6. Whereas here hydrogen is only 2. So what can I do? I can multiply it by 3. So this side is hydrogen is 3 into 2, 6. Again 3 into 2, 6. Once again we will recheck. Iron 2. This side also 2. Fine. Oxygen 3. Here also 3. Fine. No change. Hydrogen 3 into 2, 6. Here also 3 into 2, 6. So final equation is 2Fe plus 3H2O gives Fe2O3 plus 3H2. Let us balance these equations now. Now I am removing the box. You imagine an invisible box is there, so we will not touch inside. So first we will see chlorine. Chlorine is a 2 this side, LHS. Right hand side only 1. So we can make is 2 also. So this side 2, this side also 2. Now hydrogen, this side 2, this side also 2. So it is balanced equation. So H2 plus Cl2 gives 2 HCl. The same way magnesium oxide plus carbon monoxide. So let us see magnesium 1 here, here also 1. Oxygen 1 here, here also 1. Carbon 1 LHS, RHS also 1. So it is an already balanced equation. So this one you see sulfur dioxide plus oxygen gives sulfur dioxide. Sulfur dioxide, sulfur is 1, here also 1. Okay, we are happy. But oxygen here 2, 2 plus 2, that is 4. But here only 3. So next what we can make into 6. So if I put a 2 here, oxygen will become 2 into 2, 4. Here also 4. Here 2 into 2, 4 plus 2, 6. So 4 plus 2, 6. Here to make this 3, 6, what will we do? Here we will put 1, 2, so 3 into 2. This is also 6. Oxygen is 6. But here we can say that once I added 2 here, it is applicable to sulfur. Sulfur became 2. So here also it became 2. So now our equation is balanced. 2SO2 plus O2 gives 2SO3. Further to balancing, we can make the equations all the more informative by giving the states of these different substances participating in the reaction. So if it is a solid, we give S within brackets. For example, here magnesium we can give S within bracket to make sure that this is solid. Whereas hydrogen is a gas, so within brackets we can give gas G. Okay, and if it is water or a liquid form, we can write L. And if it is dissolved in water like a solution, then we can give AQ. AQ stands for aqueous. And if there is a gas evolving, like in the first case, the previous case we saw, when metal reacts with acid, a gas, hydrogen gas is evolved. So evolution of gas, an upper arrow can be indicated. At the same time, if a downward arrow, something is sedimenting or the precipitate is forming. We already balanced this equation. Iron filings reacts with the steam to form iron 3 oxide and hydrogen gases evolve. Let us see the states of matter here. Iron we know it is a solid, but here water we are taking in the form of steam, so gaseous. Iron 3 oxide is again solid, hydrogen is gas, so we can show like this, hydrogen is evolving. When magnesium is heated in nitrogen, it gives magnesium nitrate. So only by heating this reaction is happening. Here magnesium is a solid, but before that let us see if it is balanced. Here magnesium is 1, here all 3 are there, so we will make it 3 Mg. So N2 is 2, here also 2. So our balanced equation is 3 Mg plus N2 gives Mg3N2. So here magnesium is a solid, nitrogen is a gas. This is again magnesium nitride is a solid. Now next is a sodium hydroxide solution is taken. It reacts with the hydrochloric acid to form sodium chloride, which is a common salt, and water. So here let us see whether it is balanced. Sodium 1, here also 1. Chlorine, here 1, here 1. Then hydrogen 1 and 1, here 2, that is here 1 plus 1, 2 are there. Oxygen 1, there also 1. So it is balanced. We can write the states of matter. NaOH sodium hydroxide is in solution. So we write here aqueous. Hydrochloric acid is also aqueous. Sodium chloride is we are getting in a dissolved form. So we have to write aqueous, and water is a liquid form. We understood what are chemical changes, how do we represent chemical changes, what are the changes happening during a chemical reaction, and how do we write a chemical reaction, types of chemical reaction, how to balance a chemical reaction, why to balance a chemical reaction, and how can we make an equation very informative. So these concepts you learn well. We will meet in the next video with the types of reactions. Hope you understand my lessons. Please like, share and subscribe to my channel Biology My Passion. Thank you for watching.